Okay, how are we doing? Thank you for joining me. My name's Elton. I work for Docker, and I'm going to be talking to you about hybrid swarms, diverse workloads, how you can manage applications that run in Windows and in Linux in the same way, how you can deploy them, build them, look after them all in the same way, and how those containers can be different parts of the same solution. So I can have a Linux container running on one server, talking to a Windows container running in another server, and they just think they're separate components of the same system. So here's the agenda for today. So I'm going to first off talk about why containers are specific to an operating system, why you can run a Linux app in a Linux container on a Linux server, but you can't run it on a Windows server, and vice versa. So there are technical reasons for that, which basically boil down to the fact that Docker's good, but it's not magic. So I'm going to cover that. Then I'm going to say what are the benefits of being cross-platform. Like for typically, IT people tend to be in one or the other camp. So I'm a Windows guy, I've been doing Windows for 20 years, that's what I expect to do. Vice versa, I'm a Linux guy, I would never touch Windows because I don't think it's a real operating system. There's a lot of entrenched prejudices there, but there are a lot of very good reasons why you should start thinking in a cross-platform way. And then most of the session is going to be a demo. I'm going to show you how this stuff works in Docker using Docker Swarm. So Swarm is an orchestrator, which is a component that sits above the Docker engine and lets you join lots of servers together in a single cluster, and you say to the cluster, here's my application, you go and run it, and the cluster works out where to put it. So most of my demos are going to be on that. Okay, so this is a picture of a server. There's going to be more stuff on this slide, but before I get there, can I have some hands? Who's actually heard of Docker? Excellent, excellent. I'll just keep going. Who's used Docker on Linux? And who's used Docker on Windows? Okay, cool. So for those of you who didn't put your hand up for the last two things, this is the 101 slide. So Docker is an application platform. It's a new way of running applications. So if you've got, if you want to run your app in a container, what you do is this is a Windows server, but it's the same with Linux. You install Docker on your machine, and that's all you install. So in this case, it's a Windows server, so it would sit in the background as a Windows service. In Linux, it would sit there as a Linux daemon. If you want to use this as a web server or a database server or a batch server, you don't need to install anything else. You don't install, in this case, you don't install IIS or SQL Server on your machine. You just install Docker and you run everything through Docker. So if I wanted to run my web application and a batch program and a database all in containers, I do it through Docker. So I send commands to Docker to start these applications in containers. Now inside those containers, each of those apps thinks it's running on a server. It's running on a Windows server with a unique host name and a unique IP address. It's got its own file system. It's got its own registry. It thinks it's on its own server with its own dedicated resources. But actually, all of the processes that power those applications are all running natively directly on the server. So if I were to run these three containers on my Windows server and I looked at the task list, I would see the Docker daemon running, Docker D, and I would see all these three things running too. So the containers are isolated from each other, but the actual process that's running the container uses the compute of the server. There's no big layer in between. There's not like a virtual machine where my application, the thing I care about, is here, and the server that's running it is down here, and I've got all this stuff in the middle that I don't care about, I don't want or need. So the container is a lot more isolated. Okay, so why can't you run Windows containers on Linux? So I'm an MVP, so really this slide should be more like that, but there are very good reasons why you can't move these things around. So conceptually, there's an awful lot of commonality with Docker. So if I'm going to do things like build an image, in the Windows world, it's the same as in the Linux world. So I have a Docker file that describes all the things that I need for my application. I run Docker image build, and it creates me an image. On Linux, it's the same. So I have a Docker file that describes all the things I need for my Linux app. So in this case, if it's a Java web app, I've got some form of Java runtime. I've got the application server and my application going into my Docker file. I run the same Docker image build command on a Linux server, and I get an image that runs on Linux. When I want to run my application in a container, I do the same thing. I run Docker container run, I give it the name of the image, and on my Windows server, I can run my web application in a container. That would be an ASP.NET web app. Inside the container is the whole application stack, and the actual process is running directly on my Windows server. And vice versa. On my Ubuntu server, I do Docker container run with the name of my web image, and I would see Tomcat running on my server. And because of that, I can't do this. I can't say to my Linux server, run me this container from this image, which is a Windows image. Because in order to be able to run that container, it's got to be able to understand the file system, and it's got to be able to start and manage processes. And my Ubuntu server can't understand NTFS, and even if it could, it can't run an exe. It can't run a Windows service. It's got no idea how to do that stuff. So that's why you can't just take an image and run it anywhere. It's got to match the operating system that you're running it on, because actually the processes are running on the operating system. Okay, but Docker itself is cross-platform. So the Docker engine is written in Go, which is cross-platform, and the vast majority of that code is the same. So when you do Docker container run, then the code that executes that does this if it's Windows and this if it's Linux, but the bulk of that code base is the same. And the Docker command line, when you run Docker image build and Docker container run, that's just talking to the Docker API, which is coming from the service. So I can run my Windows client, and I can manage a remote Docker server on Windows or Linux, and vice versa. I can be using my Mac and I can manage a Windows server and run Windows containers. And I can cluster all those things together. So I can take my my collection of servers. If I've got a purely Windows workload, I can join them all into a cluster. We call it a swarm, and I can manage it as if it's a single thing. So some of the commands are slightly different, but actually the concepts are the same. I'm going to run my application in a container, but instead of running an individual container, I'm going to say to the swarm, here's the thing I want to run, and the swarm will decide where to run it. They're still going to be running in containers on that machine. And if I've got a hybrid system, if I've got some Linux components and some Windows components, I can still manage them all from Windows, and Docker will decide where to put my containers. So I can tell it to run an Nginx image, and it will put it onto a Linux server. And my ASP.NET image will run it on a Windows server. Okay, so why would you want to do any of that stuff? So we've already said that typically people are Windows people or Linux people. Well, there's very good reasons why you might want to embrace the other side. The first one is consistency, and I'm going to go through all these in more detail. But consistency, bigger enterprises, the larger and the older they are, they tend to have a very diverse application landscape through acquisition or just experimentation. They've got a whole bunch of stuff running in different frameworks, different platforms, maybe even different operating systems. Each of those things has its own way of being managed. And wherever there's a difference in between your systems, that means more people need to get involved. Even if all these things are automated, there's still a lot of very different automation scripts that someone's got to look after. The next one is cost, so we'll look at some numbers. And the last one is flexibility. So I'm a Windows person. I've been Windows most of my life. I hate to say it, but there are some fantastic tech stacks in the Linux world that just don't cross over. There are some platforms and there are some technologies that you can't run in Windows. But if you can run them in a Linux container, I can join them as part of my Windows solution without having to manage Linux servers, because all I'm managing is a container. It just happens to be a Linux container. So consistency. This is the sort of thing I'm talking about. So if you've got a bunch of Windows applications and a bunch of Linux applications, every part of it is different. So the build part is on the left-hand side. Maybe I'm using MS Build and NuGet to package my applications and to compile them. And then when I want to distribute them, I'm going to be using MSIs or zip files and a PowerShell script or a batch script somewhere, along with some instructions that say copy this here and copy that there. And when I'm managing them in production, I've got a whole bunch of tools. Maybe I use SCOM or IIS Manager or OMS or any one of a set of tools. And on the right-hand side, if I've also got some Linux stuff, I've got a whole different set of things. I'm building them with different tools, I'm deploying them with different tools, and I'm managing them with different tools. And in the Docker world, all that stuff becomes standardized. So the way you're going to build these things is with a Docker file. Now, inside the Docker file, you'll be using MS Build for your .NET apps, and you'll be using Maven or whatever for your Java apps. But the thing that you care about, the thing that you're working on as a team to package your application is the Docker file. You'll have a Docker file for your Windows app and a Docker file for your Linux app, and fundamentally they'll look the same. The deployment artifact is an image. So you're going to build an image in each case. When you go and share it on a registry to make it available in other environments, the registry doesn't care if it's Windows or Linux. So you manage that image in the same way, and you pull it into the desired environment in the same way. And when you manage these things, well, the Docker API means you can manage them all through the command line, or you can use any one of a number of interfaces to actually manage these things. And you can manage them all in the same way too. So you can start automating everything in the same way and managing everything in the same way. It doesn't matter what's coming in underneath. You don't really need to dive into the details of this is a Go application that's running on Alpine Linux. I don't really care. I'm going to manage it by doing Docker container logs to see the logs, for instance. Okay, now cost is an important one. It's the most boring, but it's the easiest one to quantify. So if you've got a cluster of things and they're all running Windows applications, you can join them together in your Docker Swarm. You can maybe run that in Azure, and that's going to cost you about €1,000 a month using reasonably decent machines. So that's fine. But if you were to mix that up and have Linux nodes doing the Linux stuff and just one Windows node doing your Windows apps, then you can cut a third off that monthly bill. And actually, you're not going to be running these sorts of loads, because when you go to production, you're going to have a bunch of managers to get high availability, and you're going to have multiple workers, multiple Linux workers, and multiple Windows workers. If that was all Windows, you'd be spending €2,500 a month. And if you can mix it up, then it comes down to 1,500. So that's a cloud example where it's really easy to see the difference. But also on the data center, when you start moving things to containers, you can typically consolidate very heavily. So I can throw away a whole bunch of VMs. I can get rid of those, whatever licensing I've got for those VMs, and run things on containers instead. And the other cost, which is slightly hidden, is less obvious, is a maintenance cost. And this is not meant to be an anti-Windows slide, it just happens to look like that. So when Microsoft were working on Nano Server, one of the things they did is they took a 12-month period and they worked out how many Windows updates led to a server restart. And the full Windows Server, there were 12 over the course of a year, or 11. So a Windows update means you have to restart your server. So then you've got to think about the management of all the apps that are running on that server. So Windows Server Core, when you get rid of the UI, which all your containers will, because there is no UI, you cut that in half. So you've got 6 restarts a year. Still not great, but better. Nano Server, which is the cut down version of Windows Server, doesn't have the full Windows API, but can run a lot of Windows apps, is more like 3 restarts over the year. And informally, with my own server running Ubuntu, there were none. So if you think about the management overhead of saying we need to deal with updates, it's actually quite difficult to roll that stuff out in an automated way without knowing what workloads are running on each server and whether we can do that, then there becomes a lot of overhead in that, and that's cost too. And the last one is flexibility. So there are things that are very good things in the Windows world, like .NET and SQL Server and IIS, that we just take for granted. Like they do their stuff very well, and they're not portable. So I can't run those things on Linux. And vice versa. There's some great things in Linux that don't come across. So Nginx is the web proxy, which is an incredibly performant web server. You can put it in front of your own web server to add features and add caching and stuff like that. It doesn't really work in Windows. It's been in beta mode in Windows for the last 5 years. Redis, which is a queuing technology or a NoSQL database, depending on how you look at it, you can run it in Windows, but the only Windows binary was something that Microsoft built many years ago. It hasn't been updated. So these are native Linux tools that don't come across. And back in the development phase, there's a tool called GitLab, which is a Git server and a whole bunch of other things for continuous integration and continuous deployment. That's all based on Linux, partly because it uses Nginx and Redis under the hood. So those things don't come across. So they all run happily on Linux. They don't run on Windows. But if you can run those things in containers, you can start mixing them up. Okay, so my demo app is, if you were in my lab this morning, it's the kind of continuation from the app I was building up there. So it's all on GitHub, so if you want to go and see, you can see what it looks like. It's a distributed application. It's the kind of end result of doing a modernization program. So at the start of this, I've got an ASP.NET web application talking to a SQL Server database. And firstly, I take that monolith and I run it in a container, and I run SQL Server in a container, and then I start breaking features out, which is what our customers do when they take their old applications, they move them to Docker. Docker gives them a platform to start modernizing it without having to completely rewrite it. So you can take out the key features, run those in different containers, and just plug it all together with Docker. So these containers are all blue because at the moment they all run in Windows. I've got my web application at the top, which is an old ASP.NET Web Forms app. What that does when users interact with it is it drops a message onto a message queue. That's running in Windows, and then off the back of that, there are 2 message handlers that listen for those events that are published. One of them stores data in SQL Server, and the other one stores data in Elasticsearch, which has a analytics UI called Cabana, so people can search the data it's a reporting database and a transactional database. So all those things are currently running in Windows. So what I'm going to show you is how you can take those open source parts of that solution. So the message queue I'm using is called NATS. That's an open source cross-platform message queue. It scales ridiculously. It's hugely performant. It's an enterprise-grade thing that you can just drop in as a container. And the same with Elasticsearch and Cabana. Elasticsearch is a document database. You can cluster it. You can run multiple instances of it. Again, it's enterprise-grade, production-grade equipment, and Cabana as well, which is the front end for Elasticsearch. They're all open source, so I could run those in Linux containers. And that's what I'm going to be doing. So I'm going to show you how this stuff looks. So first of all, let me show you what's running here. So let's start up Docker. And if you're wondering what I've got on this web page, on my GitHub repo, I write down all the stuff I'm going to do in a demo. So if you want to, you can follow along afterwards, and to prove that it's not fake. Although, you know, if it doesn't go well, then I'll start faking it at some point. So, if I run Docker version, so this is, the Docker version command does two things. Like I said, the command line talks to an API, and the version command tells you the output of both. So, as it happens, I'm running, my client is 1709, running on Windows, and I'm talking to a server which is 1709, running on Windows 2. So that's my local machine. So if I wanted to run containers on my Surface, that's what I would use. But if I want to run, I've got a remote cluster. So this is my cluster running in Azure. I've got I've got a manager node, which is in Linux. I've got a Linux worker node, and I've got a Windows worker node. So I've just got 3 machines. This is because Docker's platform independent, you can use whatever kind of infrastructure management that you want to use. So these happen to be running in Azure, so I can use an ordinary Azure dashboard. So if I want to connect to that remote swarm, I've got a script in here which does that for me. So all this environment script does is it sets up some settings, like it tells Docker where to find my host, and it tells Docker where to find the certificate for secure communication between my machine and the remote swarm. So now when I run this, it sets those variables up, and when I run any Docker commands, I'm going to be running against my remote swarm. So now when I run Docker version, I've got my version at the top is the same because it's my client, and here I'm talking to the Linux node. So that's my master. So the way that swarm mode works, the way that most orchestrators work, is there's a manager role and there's a worker role, and you talk to the manager and it schedules work on the workers. So if I run docker node ls, you will see the list of all the nodes. I've got my manager, I've got an Ubuntu worker, and I've got a Windows worker, and they're all just sat there kind of waiting for things to happen because there's not much running there at the moment. Okay, so let me show you what I'm going to deploy. So I have, go back to my session. So in here, if I show you what I've got Visual Studio Code running with all the stack files, which are the descriptions of my application. So I'm going to deploy this, and then I'll walk you through the stack file. So I'm going to do a docker stack deploy. So this is going to take my definition of my entire solution, and it's going to give it to the manager and say, run those things in containers. So the file I'm going to start with is called version 1, and the stack is called newsletter. So that's going to create a whole bunch of stuff. And the stuff it's creating is the stuff that's in here. So if you're not familiar with this, this is a Docker compose file. So a compose file is like a runbook. It says all the bits that are needed for my solution and how they plug together. So for each of these components, there's a Docker file. So there's a script that says how to build my database with my schema, and there's a script that says how to build my web application. And the Docker compose file is how to join all those things together for a full running solution. So in here, I've got my database. I've got a message queue, which is my Nano Server. I've got Elasticsearch for the document database. I've got a message handler, which listens to events that are published from the website and saves them in Elasticsearch. And I've got a Cabana, which is my front end for my analytics. I've got another message handler, which listens to the same events and saves them in SQL Server. So I've got a transactional database and a reporting database. And I've got my web application, which is my ASP.NET Web Forms app. So all those things are defined in this Docker compose file, which is like a runbook, and I'm using some of the features that you get in swarm mode. So one of the features is secrets, so I can store confidential things like a connection string in the swarm. So if I go and look at my swarm, so that's all finished deploying. If I clear this and look at my secrets, I've got a bunch of secrets that are already created. And what that secret is a first-class citizen in Docker. So like I can do Docker run me a container, I can say Docker create me a secret. And here's the content of my secret, which could be a chunk of XML for a connection string or JSON or whatever. Once I've saved them, they're encrypted in the swarm, and they're only delivered to a server if it's going to run a container that needs that secret. And they're only available in plain text inside the container. So inside the container, I will see a file, and I can see the contents with my connection string or whatever it might be. Externally, I can't see the content anymore. So even an administrator, I can't see what's inside this secret. It's all encrypted in the swarm. And what I've got in my runbook is I'm saying inside my web application, I'm using a secret for my connection string. And that way I've taken my old application. I haven't had to change any code to make that happen. So inside the config file, I'm saying, here's where you'll find your connection string. So I'm not changing code, but I'm integrating with the extra benefits I get from the platform. Okay, so let's go and have a look at this. So I should have a whole bunch of services running now. So there are various things in here. You'll see that there's one of one replica. And a replica is how you get high availability. So if I had lots and lots of servers and I wanted to run 10 instances of my web container for availability and scale, Docker would make sure that there are always 10 running. If one of the servers is running 3 containers and that server goes down, then the swarm will bring up another 3 to replace it somewhere else. It's like a service level. But I'm only running one each of those. Okay, so that's all running. So I'll go and browse to my website and I'll show you what this thing looks like. And it'll take a moment or two to start up. And that's because my application is an old application. It doesn't do nice things like preloading the site, so it's fast to start or anything like that. What it does when you first browse into it, it's going to hit effectively a cold web server. So the IIS is up and running, but there's nothing listening to my process until I send a request in. So when the request lands, then this will fire up, and it uses Entity Framework. So the database I've connected it to is actually an empty database. It's a completely fresh instance of SQL Server. So when the application starts, it spins up the worker process, it connects to the database, it sees it's empty, deploys the schema, deploys the reference data, and then it comes back to me. So the fact that I've put this in a container doesn't automatically mean I've got a highly scalable web application. It's still my old app running in a container. Some features I've broken out, but actually it's still the core of the monolith is the same. So this is my demo application that if you've seen me present, you've seen this a million times. I'm going to do a new one for next year. So we've got this tool called Image to Docker. It's an open source PowerShell tool. The tool is real, although this newsletter is not real. You can take Image to Docker and you can point it at a VM that's running an ASP.NET application, and it can extract that application and write you the Docker file for it. So it's a really easy way of getting started. And it can work with .NET 2 apps that are running on Windows Server 2003. So it's a good way of saying, here, I've got a bunch of things here. I'm going to use the tool to get up and running with Docker. But this application here is just a fake newsletter. So if I put some stuff in here, you can see I've run this lots of times before. This information here is coming from the database. So that's come from my reference data that gets deployed when the application starts. So I know it's talking to something. And when I put this stuff in here and click on Go, what happens is this, oh, look at that. See, like I said, just moving it into Docker doesn't mean everything's suddenly fine. So what this is saying is it can't connect to the message queue. So that's probably because, let me see what's going on here. Inside my message queue. Cool. Okay, so let me switch to the UI because the UI is going to be easier to see. So the very first demo failing is always a bad sign. So what I've got here, the swarm that I'm using is actually running Docker Enterprise Edition. So I can manage that through the command line like I just have, or I can manage it through the UI. So in here, I've got a whole bunch of containers that are running my application, and you'll see in here somewhere, I've got my message queue. And I can go and view the logs. So this is the same as doing Docker container logs, but I've got a nice user interface with this, with a whole bunch of role-based access control, so I can decide what's happening when it runs. So that looks okay. So that's all started up. If I need to, I can connect to that container, and I can run a shell and see what's happening. And I can do whatever commands I need to in here. So this is how you would debug if there was a problem like there is. So I'm going to do ipconfig to make sure it's got an IP address. That looks good. And I'm going to ping my sign up web app. I'm going to do that from the web application actually. Okay, so I suspect all that's happened is this is a startup issue, and my web application has started before the message queue is ready to receive requests. So I'm going to restart my web application. So like I said, this application is old, and it doesn't do nice things like doing restarts when it makes a connection. So it looks for a connection, it doesn't find one, and then it ends. So obviously that's why things like this happen. So let me restart that, and then afterwards that should be cool. Service update, and if I force it, so you will see during the demo as I move things along, this will happen later on as well. Okay, so that's going to restart that. So if I go and look at my services now, I will see my web application. I should have a new task running. Yeah, cool. So one has been shut down, that's the old one, and I'm starting up a new one. So when this starts, I can look at the logs. That's what my web application puts out when it's running, and I can also connect to this container. So if I run PowerShell in here, and I can just confirm that my web app can connect to my message queue. So ping. So this live debugging exercise is not part of the script, but you know, it shows you that it works. Okay, cool, so that's fine. So that's a startup issue. So that's because I've taken my old application and I've moved it into Docker, but that doesn't necessarily mean everything's going to be perfect. So when I browse to this again, I'm going to go put some more details in. Let's refresh that. So as you go along the spectrum of saying, I've got my application, I've moved it to Docker, I'm going to modernize it, one of the steps you will do is to say, this application needs to be resilient. So in the Docker world, containers are meant to be disposable. So I can run my web container for months and months and months, but when I've got a Windows update to do, I'm going to throw away that container and run a new container from a new image. So in things like this, when there are transient failures, if I wanted to update my message queue and replace it with a new instance from a new version, my web container would need to be resilient to that. If it fails to make a connection, thank you, then it should retry. That logic isn't in my app because it's an old app. But that's what I would do as I start moving on down, because then if I've got that retry logic, then I can start doing smarter things. Okay, so the thank you page, what's happened here is it's published an event to the message queue, and that event has then been picked up by my message handlers. So I've got my one handler is going to put it in SQL Server, which is running in a container, and my other handler is going to put it in Elasticsearch, which is running in another container. Now I can browse to my Elasticsearch front end, which is here. And Elasticsearch is on port 5601. So this is running. This is running in a Windows container still. So I need to browse to the right URL. Excellent. Okay, don't copy it then. Hey, 5601. Okay, so this is Cabana. Cabana, if you're not familiar with it, it's just a web front end to Elasticsearch, which is my document database. So what Cabana can do is it can connect to Elasticsearch, and it can find the documents that are in there, and it understands the structure of the documents. So assuming that my console apps were able to connect to the message queue, excellent. It's found there's a whole bunch of fields in there, so it knows that the prospects is the collection where my documents are, and when I click create, it will go and look at all the fields, and they're all there, and I can discover, and it will show me the data that I've just put in. So there's my dummy data that I've put in there. So I'm not going to show you SQL Server just yet because that's running in a container which isn't publicly available. So you wouldn't do that in production, but in a test environment, it's really handy to say, my application uses SQL Server for some part of what it does, but that SQL Server database should only be visible to my other containers. So I haven't made any of the ports for SQL Server available publicly, so I can't connect to it from outside of Docker. I can still run commands in there if I wanted to, but I wouldn't be able to connect to it from outside. Okay, so that's version 1 of my app, which should have taken 2 minutes, so we're doing really well. And the next version is going to start shifting some of that stuff over to Linux. So my next deployment file has only got one thing in it. It's got my message queue in there. And what I'm saying here is when I deploy this, it's going to say I'm deploying it to the same stack, and one of the definitions has changed. The message queue definition has changed. So I'm going to run that somewhere else. And the definition that's changed is the image type. So I'm running NAT still, which is the same message queue component, but it's the Linux version. So this is going to run in a Linux container. And I'm giving Docker a hint of where to put it. So Docker will, when you ask the swarm to run a container, the scheduler looks at what's running in the swarm, and if there are any, it'll assign the task to the node with the most available resources. So it looks at CPU and memory, and it sees which one's working harder, and the ones that aren't working so hard get the next task in the list. At this point, it doesn't look to see if it's a Linux container or a Windows container. So it could be that my Windows server gets a request to run this, it pulls the image down and then finds it can't run it, fine, then Docker moves on to the next one. But if I know it's a Linux container, then I might as well tell Docker that, and it will. This hint basically says only run it on a node, on a server that is the operating system is Linux. So I'm just giving it a hint. There's only one definition in here, so it's only going to replace one thing. So let's go back here. There's my Docker file. So I'm going to do a Docker stack deploy. And my file this time is version 2, and it's the newsletter. So the only thing it does is it updates that message queue definition. So it's taken this stack file as a desired state, but it sees it's only a partial state in there. So it's going to replace my message queue container running on Windows with a message queue container running on Linux. So now if I have a look at my services, Docker service ls, I will see there's a whole bunch of things in here, and if I inspect my message queue, so now it's running my Linux image, so it knows it's a Linux image now. If I inspect that and have a look at the containers, we'll see that there was the message queue version 1 is shut down that was running on my Windows server. And that was the Nano Server variant of NAT, so that's a Windows container. And the new version, which is running, is on my Ubuntu worker, and this is the Linux variant. So it's moved that and it's changed it around. Okay, so I've still got the same service name, so this service is still available as the message queue service, but as we've seen, my web app doesn't actually, my web app isn't resilient. So what it's going to do is if I try and use this application now, the web container inside the logic that connects to the message queue, it caches the location of the message queue. And it will have an IP address which refers to a Windows container that's no longer there. So rather than go through all that again, I'm going to preempt that by restarting my service. So the service update command, if you pass the force parameter, then it just restarts it. So I'm going to restart my newsletter web application. Let's put the underscore in. And in order to be safe, I'm also going to do my handlers. So anything that's got a connection to my message queue, I'm going to restart so that to make sure that it has the latest connection when it tries to join. So I'll do that with my save handler too. So the reason for doing that is because, again, these are old applications. They don't have the retry logic, and they're doing their own caching. So another thing you will typically find with older applications, when they lived in a world where everything was static, caching comes in to try and make things more efficient. So if I've got my web application and it's talking to a message queue, when I make the connection, it's going to resolve the IP address of the message queue server, and it will store that in its local cache. And it may store that indefinitely. It may never come back to the DNS server to find out if the IP address has changed, because it doesn't expect it to change. My message queue is running in a server. That's it. It's going to be running there forever. So they don't do retries. They do aggressive caching, and they don't check to see if things have changed. By restarting that now, I'm getting past the fact that the cache is pointing to something that's no longer there, and I'm jump starting to my new version of my application. So moving these things from Linux to Windows doesn't necessarily mean you can do this in production without testing it, and there may be some downtime for your application, but you can still do it. So this is the new version of my web application. It's starting up again. It's going to connect to my database and check that the schema is all up to date. So this will come back in a few moments. And my Cabana application is no longer here. Oh, that comes in later on. So my Cabana application will be here for up until the next demo. Okay, so same application. This is still running in a Windows container. But now, when I put this stuff in, it will be saving it to my Linux container using Linux for my message queue. There we go. So that's still there. My Cabana is the same. So if I refresh this, okay, so now I've got two sets of data in there. So I've swapped out the message queue. I've restarted what should have been the transient containers anyway, my web application and my message handlers. And so the workflow is exactly the same. There's a tiny bit of downtime to allow for the fact that my application is not resilient to things being swapped out underneath it. But I have managed to swap that out, and now I'm running that in a Linux container. So if I had a whole bunch of Windows boxes to run my message queue, I could potentially decommission some of those now and just have the same workload running but on Linux servers. Okay, so I've moved that message queue, and the next thing to do is to do the same with my Elastic Stack. So I'm going to take my version 3 compose file, and again this redefines two parts of my solution. So I'm redefining Elasticsearch to use a Linux image, and I'm giving it the hint to run it in a Linux container. So say this is run this on a Linux server. So I'm going to take away my Windows version of Elasticsearch and throw it away and replace it with a Linux version. And the same with Cabana. Use the same Cabana definition, but use now Linux and run it on a Linux server. Okay, so let's go and see this running. So I'm going to do the same Docker stack deploy. And my file is my version 3, and it's called newsletter. Make sure I get that right. Cool. So again, it compares what's currently running in the stack. So by name, I've called it the newsletter stack. It compares what's currently running to what's defined in the stack file, and two things have changed. It's going to update those. So I will see also here that my services are now running on my Linux node. So likewise to my message queue, my Cabana container, for instance, I should have two containers. One was the original one that was on my Windows node that shut down, and the new one is already running. It's on my Linux node. So by doing that, what Docker does is it says, I've got one Linux node that's free to run tasks. I'm going to instruct it to run this container instance. It goes and pulls the image, starts the container, and joins it to the network, to the virtual network. So all these containers are in the same Docker network, and that network spans all my nodes, all my servers. So my Windows node that's running over here is attached to a virtual Docker network with its Windows containers. And so when my web application talks to my message queue in a Linux container, that's fine because it's going to use this virtual network where all these containers can see each other. Okay, so let's go back over here. So the app's the same. So if I go back here, nothing's changed with the front end or with the middleware. It's the reporting side that's changed. So if I put in number 3, and click on go. So it's still dropping a message to the queue. The queue is running in Linux, doesn't matter. It can connect each other by service name. My message handlers are picking that up, and they're going to store it in Elasticsearch, and Cabana can access it. Cabana now is no longer on my Windows box. So if I refresh this is going to eventually time out and say there's nothing listening there, because I've shut down that container that was hosting that service, and it's running somewhere else now. And where it's running is on my Linux box. So if I browse to this, port 5601, so here's Cabana. It's exactly the same version of Cabana. It just happens to be in a Linux container on a Linux box now. So Cabana is a Node.js application, so I can run it pretty much anywhere. And same with Elasticsearch. Elasticsearch is a Java application. Wherever I can run the Java runtime, the JVM, I can run it in a container. But by running it in a Linux container, it's more lightweight. It's got a smaller attack surface because I don't need the full Windows API, and it's easier to move around. Okay, so here's my Cabana container. This is the new version of Cabana, and so this is the same problem as before. My handler had a connection to Elasticsearch that it's cached. And so when it received the message to say, save this in Elasticsearch, it's going to try and talk to Elasticsearch on my Windows container that's no longer there. So Docker's done everything that I needed it to do, and any scheduler would be exactly the same. But my underlying application doesn't have the smarts to check and see what's happened. So if it had retry logic in the Elasticsearch client, let me do this to do an update. If my console application that's listening for those messages, if it had the retry logic, it would say, I'm going to save this to Elasticsearch. That fails, so I'm going to invalidate my cache of where I think Elasticsearch is and go back to the platform to ask where to find it. So service discovery is built into Docker, and it's just DNS. So as long as the client says, where do I find the server called Elasticsearch, Docker will give it the IP address of the container. But if the client stores that and the container moves, then the client's got an invalid reference. So again, I've restarted that. So now when I go back here and put that through again, the message queue is still there. Now my handler should pick that up and it should save it to the correct Elasticsearch. And I can check that by going to Universal Control Plane and having a look at my containers. So in here, find my services, I've got a message handler for the indexer, and I can go and look at the containers, and there's just that one that's running. If I view the logs, so this is the logs for my container that's telling me it's connected to my message queue, it's found a message that's been sent through, and it's indexed my prospect. So it's managed to save that now to Elasticsearch. The previous one would have had an error in there telling me that it couldn't find Elasticsearch. So now in Cabana should connect to that collection. If I type that in properly, prospects. Come back here. And there's the data in there now. So again, you can do this stuff, and the scheduler will take your old application and run it in a new platform without you having to change it, but you're not necessarily going to get all the benefits of a brand new design. You can start splitting features out, but if you're not going to allow for the fact that you're now running in a different platform and you don't have the lifetime guarantees that you expect, where your database is always going to be over there and your message queue will always be here, then you're going to hit problems like this. So there's my data now. It's a completely new instance of Elasticsearch. So there is none of my existing data that was there from version 1 and version 2. I've just got my version 3 in there. So now I've got Elasticsearch in Linux container. I've got Cabana running in my Linux container, and I've got my message queue running in Linux. The only things that are running in Windows are the things that have to, because they don't port across. So my web forms application, I can't run that in anything other than Windows Server. It's a full ASP.NET application, and my message handlers are full .NET console applications. Now, if I wanted to port them, I'd have to rewrite them. I could rewrite them in .NET Core, and then I could run them in Linux and get rid of the Windows stuff altogether. But then there's going to be a balance of how far you want to take this stuff. Okay, so the last thing I'm going to do, I haven't shown you anything going into SQL Server for the simple reason that SQL Server at the moment is running in a container and it's locked down, so I can't actually access it unless I was to connect to the container and run some commands. The final thing I'm going to do is show you how you can integrate not just with a hybrid workload within your cluster, but with services outside of the cluster. So in here, my version 4, I've got redefinition for my save handler and for my web application. I'm using the same images, so it's exactly the same content that's going to be running in my container, the same application, but I've changed where the secret is coming from. And instead of using a connection string that points to a local SQL database in a container, I'm pointing to SQL Azure now. So that's fine. So my app in a container can easily talk to an external service, whether it's SQL Azure or whether I'm on AWS or whatever. And the only thing I have to change is the connection string, because everything else is already in the app. And I can do that without having to rebuild or anything like that. The only thing I'm changing is where the connection string is coming from, and that contains my Azure connection string. So I'm going to do a Docker stack deploy, and this is version 4. Let's span it around. And it's the newsletter. And again, you'll see the only things that change are the save handler, which actually saves to SQL Server, and the web application, which reads the reference data from SQL Server. So they're both restarting, and they're using the connection string that's pointing to Azure. I can't show you what's in that connection string because I'm not in a container. If I was in a container and I had the secret available to me, I could, but I'm not, so you're going to have to take my word for it when I put the data in. Okay, so browse to my application. Again, this application doesn't have a health check in there, and a health check is how you can tell Docker to test that your application is running correctly. And one of the side advantages of a health check is the health check runs inside the container. So for a web application, you would have a health check that does something like make a request to the local host and check that I get a 200 response. If I do, then my application's healthy. But also, if the first thing that makes the connection is the health check, then the end user doesn't hit a cold server. So as you're moving through to get your Docker containers production ready, you would do things like put a health check in there, make sure that they're resilient for changes, all that sort of stuff. Okay, so I'm going to put this in here now. This is version 4. And same information. This is coming from my SQL Azure database, but it's just connected in using the schema that's already there. So I should see now, if I go back to my universal control plane, and if I have a look at the logs from my save handler, which is here, I've got a new container running this. It's been up for 1 minute. And if I look at the logs, I've got a prospect ID of 1, which is my new data that's in there. I can connect to SQL Server now. This is SQL running in Azure. And if I look for my prospects, when this comes back, I should see my new prospect in there. There we go. There's my number 4 prospect that's been put in there. So now I've integrated my container application with the outside world. Okay, so that's it for the demo stuff. So just to finish up with a couple of closing notes. So this is what my application looks like now. I started off with everything running in a Windows container, and now I'm running the bits that are cross-platform in Linux containers. And I manage them all in the same way. If I want to see what's happening inside, I can use either the Docker command line or the UI to find out what's going inside my applications. And I can also go and connect and debug. And I'm connecting to SQL Server in Azure. So I don't necessarily want to have the overhead of managing my transactional database in a container, so I can just plug it into a managed service. And I've shown you Docker Enterprise Edition. So I've got a bunch of Windows and Linux servers running Docker EE, which gives me the management UI. At the moment, you can't do this in Kube because Kube doesn't have Windows support, but it's coming soon. So Kubernetes is an alternative orchestrator. It's an alternative way of scheduling work on a cluster of machines running containers. Windows support is coming soon, probably by the end of the year. So you'll be able to take your Docker images and choose where you run them. And Mesos, which is the other alternative orchestrator, which is from Apache, they did a blog post in 2015 saying that Windows support was coming. It hasn't yet, but when they do get it there, you'll be able to do this there too. Okay, so takeaways of that fast walkthrough. You can only run Linux containers on Linux because you can only run Linux apps on Linux and Windows on Windows. You can't cross those things over at the moment. If you move to a hybrid model, you can pick the right things for each job. So you can pick the right tools that give you the best combination of features and affordability. And you can manage everything in the same way. And that's a really big deal if you've got an IT team which is basically split in two with Windows people and Linux people. Suddenly they can manage everything in the same way. And with Docker, you can use what I've been showing you on the Enterprise Edition. It works exactly the same in the Community Edition. So it's all part of Swarm mode, which is part of the free offering. And if you're interested in seeing some more of this stuff, the application that I've shown you as the end state, I did a video series showing how to get there. So that's on YouTube. If you want us to come in and talk to you about how you can make your apps running Docker, we've got a funded program to make that happen. If you're not doing anything next week, come to Copenhagen. Slightly late notice, but that's our big DockerCon conference. You can get a t-shirt like this, use that code, Elton10 to get 10% off. And then I talk about this stuff all the time. So that's me on Twitter. Like, my job is talking about Docker. So if you're interested, follow there. And thank you very much. I'm out of time, but come and see me afterwards if you've got any questions.